Is this an open message to America's global competitors? Or simply an expensive show of force? Here's what happens when one of the fastest bombers and one of the stealthiest bombers are brought together for a single mission. Segment 1. Two bombers, two philosophies. Imagine two United States bombers flying within the same strategic picture. The first has a shape that has been familiar for decades, the B-1B Lancer. The second, however, looks as if it comes from an entirely different era, the B-21 Raider. Both are designed for long-range missions. But there is one fundamental difference. The B-1B represents a philosophy that places strong emphasis on speed, range, and flexibility. Meanwhile, the B-21 is built around a philosophy that places greater emphasis on stealth, data networking, sensors, and survivability in high-threat environments. And this is where the story becomes interesting, because the future of air power is not always determined by a single aircraft that is the fastest, or one that is the hardest to detect. What matters far more is how different capabilities complement one another. So, when we talk about the B-1B and B-21 as a duo, we are actually looking at a major shift in how the United States approaches long-range air power. It is not simply about aircraft. It is about how speed, stealth, sensors, networking, and payload capacity can work together within a single ecosystem. And to understand why this concept matters, we need to take a step back, because the B-21 did not appear out of nowhere. It is the result of decades of evolution in military aviation technology. Segment 2. From strategic bombing to the sensor era. The concept of the strategic bomber evolved alongside advances in aviation technology. In the early 20th century, aircraft were first used for reconnaissance and later developed into tools capable of striking targets from the air. World War I demonstrated that aircraft could reach areas that had previously been difficult for ground forces to access. Then, World War II dramatically expanded the use of air power. However, history also shows that aerial bombing can have enormous humanitarian consequences. For that reason, discussions about strategic bombers cannot focus solely on engines, range, or payload. There are historical, legal, strategic, and humanitarian dimensions that have always accompanied their use. After World War II, technology continued to evolve. Intercontinental ballistic missiles emerged. Ballistic missile-carrying submarines became part of the equation, and the concept later known as the nuclear triad took shape. Within this structure, bombers offered a unique capability. Unlike missiles, which cannot be recalled once launched, an aircraft can change course, be withdrawn from a mission, or be used for different types of operations. This is where flexibility becomes extremely important, and that characteristic helps explain why bombers have remained relevant even as missile technology has advanced rapidly. But a new problem emerged. As air defense systems became more sophisticated, it became increasingly difficult for a large aircraft to approach areas protected by layered defenses. So the question became, if speed alone is not enough, and a large aircraft is easier to detect, what is the answer? One possible answer is stealth. Segment 3. B-1B Lancer Speed AS and Advantage. The B-1B Lancer emerged from an era when speed and penetration capability were important elements of bomber operational concepts. The aircraft uses a variable sweep wing design. In simple terms, the position of its wings can be adjusted depending on flight conditions. When certain characteristics are needed at lower speeds, the wing configuration can be adjusted accordingly. When high-speed performance is required, the configuration can also be changed. This concept provides aerodynamic flexibility. The B-1B is also well known for its ability to achieve high speeds while carrying a substantial payload. But technology continues to evolve. The threats facing modern aircraft are no longer limited to enemy fighter aircraft. There are ground-based radars. There are sensor networks. There are layered air defense systems. There are passive sensors. And most importantly, all of these systems are becoming increasingly connected through digital networks. This means an aircraft does not necessarily have to be engaged to be in danger. If its position can be detected, tracked, and shared with other systems, a threat can emerge long before the aircraft reaches its intended area of operation. This is where the concepts behind the B-1B and B-21 begin to look different. The B-1B offers speed and capacity. The B-21 takes an approach that places greater emphasis on reducing the probability of detection from the very beginning. And that difference leads us to the next question. What exactly does stealth mean? Segment 4. Stealth does not mean invisible. The term stealth is often misunderstood. A stealth aircraft does not mean that it can magically disappear from radar. No technology can make an aircraft completely invisible under all conditions. A more accurate definition is reducing the probability of detection and tracking under specific conditions. One important factor is radar cross-section, or RCS. Simply put, RCS describes how large an object appears to a radar system. The aircraft's surfaces can be designed to redirect radar energy away from the radar source. Certain materials can also help manage those reflections. But stealth is not just about the shape of the aircraft. There are many other factors involved. The engines, the air intakes, the aircraft surfaces, panel joints, weapon bay doors, even the way an aircraft operates its electronic systems. That is why building a stealth aircraft is not simply a matter of creating a futuristic-looking design. It is a multidisciplinary engineering challenge. Aerodynamics have to work. The engines have to work. Cooling systems have to work. Electronics have to work. And everything must remain within reasonable limits of weight and cost. The B-21 is particularly interesting because its design was developed from the outset with an operating environment heavily dependent on sensors and networks in mind. But there is one aspect that may be even more important than its physical shape. And that is, what happens when the aircraft begins receiving data from multiple sensors? Segment 5. The B-21 is more than just a stealth aircraft. The B-21 is often discussed because of its futuristic shape. But its most important technology may actually be the part that cannot be seen from the outside. The B-21 is designed as part of a digital ecosystem. This concept is closely related to open systems architecture and network integration capabilities. Why is that important? Because military technology is evolving extremely quickly. New sensors emerge. Software changes. Communication systems advance. Data processing methods also evolve. If an aircraft relies on an overly closed architecture, every major change can require a long and expensive integration process. An open architecture is intended to provide greater flexibility. In the context of the B-21, the aircraft is not simply a platform for carrying a payload. It can be viewed as a node within a network. Imagine an environment where information comes from multiple sources. Airborne radar, early warning aircraft, satellites, other aircraft, ground-based sensors, and communication systems. All of that data then needs to be processed. The challenge is not simply collecting data. The real challenge is turning data into information that can be understood and used quickly. This is where computing and software are becoming increasingly important in next-generation aircraft. And this creates a major shift. In the past, an aircraft's advantages were often highly visible in its physical characteristics. Today, some of its most important advantages may actually exist inside the computer. Segment 6. Sensors, the invisible eyes. In modern warfare, information is one of the most important factors. An aircraft may have powerful engines, but if the pilot and the aircraft systems cannot understand the surrounding environment, that capability becomes limited. That is why sensors are so important. Modern sensors can help detect objects, identify sources of emissions, understand the surrounding environment, and build a picture of the overall situation. But there is a major challenge. The more sensors that are used, the more data they generate. And too much data can also become a problem. If humans have to process everything manually, an overwhelming amount of information can slow down decision-making. That is why modern systems increasingly rely on computers to help filter and combine information. This concept is often called sensor fusion. Simply put, sensor fusion is the process of combining information from multiple sensors to create a more complete picture. For example, one sensor may provide positional information. Another sensor may provide emission characteristics. A third source may provide information from a different area. When all of this information is combined, the system can develop a more comprehensive picture than any individual sensor could provide on its own. And this has become an important development in the evolution of modern fighter aircraft and bombers. The B-21 is not only about being difficult to detect. It is also about how the aircraft understands the environment around it. But one question remains. If the B-21 has capabilities like these, then what role does the B-1B play? Segment 7. Why is the B-1B still relevant? This is where the concept of a duet becomes interesting. The B-1B and B-21 should not necessarily be viewed as two aircraft simply replacing one another. They have different characteristics. The B-1B has extensive operational experience. It has a large payload capacity. It can operate at high speed. And for decades, the platform has remained an important part of the United States long-range bomber force. Meanwhile, the B-21 is a new generation platform designed to operate in a very different technological environment. So instead of asking, which one is better? A more useful question is, what can each platform do that the other cannot easily replicate? In modern military analysis, this type of question is far more relevant, because air power rarely depends on a single aircraft. There are tankers. There are reconnaissance aircraft. There are early warning aircraft. There are communication systems. There are satellites. There are command networks. And, of course, there are the people operating the entire system. In other words, the strength of a platform is not determined solely by its individual specifications. It is also determined by how effectively that platform integrates with the broader ecosystem. And this is where the concept of a B-1B Lancer and B-21 Raider duet begins to make sense. Segment 8. Speed versus stealth. At first glance, we can see the B-1B Lancer and B-21 Raider as symbols of two different approaches. The B-1B represents the idea of moving quickly, carrying a large payload, and maintaining high flexibility. The B-21 Raider represents the idea of reducing its signature, relying on networks, and improving survivability in high-threat environments. But in reality, this is not a simple contest between speed and stealth, because speed has value as well. Speed can reduce the time required to move from one area to another. Stealth also has value. Stealth can help reduce the probability of detection and tracking under certain conditions. Sensors have value. Networks have value. And payload capacity has value as well. So the future of air power will likely not be about choosing a single characteristic while sacrificing everything else. Instead, it will be about combining different capabilities. Imagine an ecosystem. One platform provides greater penetration capability. Another provides substantial payload capacity. Another provides information. Tankers extend operational range. Networks connect everything together. In such a system, an aircraft no longer operates entirely on its own. It becomes part of an architecture. And this architecture may become one of the defining characteristics of next-generation air power. Segment 9. The B-21 and the Family of Systems concept. One of the most interesting concepts surrounding the B-21 is the idea that the aircraft does not operate on its own. It is being developed as part of what is often referred to as a family of systems. This means the capabilities of an aircraft are viewed as part of a broader network of interconnected systems. This is important because modern warfare is becoming increasingly connected. An aircraft can receive information from other sources. One sensor can support another platform. A communications network can connect multiple units. And software becomes the layer that ties everything together. This concept also explains why B-21 radar technology is about much more than the shape of its wings. When we look at a stealth aircraft from the outside, we are seeing only a small portion of the technology actually involved. Inside, there are computers. There is software. There are sensors. There are communication systems. There are mission management systems. There are navigation systems. There are maintenance systems. All of them have to work together as a single system. And this is precisely where one of the biggest challenges for next-generation aircraft lies. It is not simply about making an aircraft fly. It is about creating a complex platform that can continue to evolve for decades. Segment 10. The biggest challenge, keeping an aircraft relevant. There is one reality that is often overlooked when discussing next-generation aircraft. Technology does not stop evolving when an aircraft is completed. In many ways, that is when the long journey begins. An aircraft designed today must face sensor technologies that could evolve dramatically over the next 10 or 20 years. Electronic threats change. Software changes. Communication methods change. Operational requirements change. That is why the ability to perform upgrades becomes extremely important. This is where open systems architecture becomes relevant. If the design allows certain components to be updated without completely redesigning the aircraft, modernization can become more flexible. This concept does not apply only to aircraft. We can see a similar pattern across many modern technologies. Smartphones receive software updates. Modern vehicles increasingly depend on computers. Civilian aircraft are also becoming increasingly digital. The difference is that military aircraft operate in a far more complex environment. A small error can have significant consequences. That is why integrating hardware, software, sensors, humans, and communication systems represents an extraordinary engineering challenge. And this brings us to why the B-21 radar is often described as part of the future of air power. Segment 11. What is actually changing? If we look at everything from a distance, the B-1B Lancer and B-21 Raider appear to be two bombers from different generations. But the real transformation goes much deeper. The B-1B emerged from an era when characteristics such as speed, range, and payload capacity were major factors in aircraft design. The B-21 has emerged in an era when information and connectivity are becoming just as important as the aircraft's physical capabilities. This does not mean speed is no longer important, nor does it mean stealth is a perfect solution. In reality, every technology has limitations. Stealth does not make an aircraft invulnerable. Networks do not guarantee that communications will always be available. Sensors do not always provide perfect information. And speed does not solve every problem. That is why the real strength lies in the ability to consistently combine these different technologies. The B-1B can be viewed as a product of one era, the B-21 as a representation of the next, and the transition between them reveals something much bigger. Air power is moving from a platform-centric concept toward an increasingly network-centric approach. Aircraft remain important, but the networks connecting aircraft with sensors, communication systems, and other platforms are becoming increasingly decisive. That may be the most important change to understand. Segment 12. The future, not who is strongest, but who is most integrated. So, does the combination of the B-1B Lancer and B-21 Raider truly mark the beginning of a new era? The answer depends on how we define a new era. If we look only at speed, the B-1B has embodied that concept for decades. If we look only at stealth, the B-21 is certainly not the first aircraft to use the technology. But when we look at everything as a system, the story becomes far more interesting. The B-1B represents capabilities that have evolved over decades. The B-21 introduces a newer approach that emphasizes next-generation stealth, sensors, networking, software, and adaptability. And when different platforms operate within the same ecosystem, air power is no longer determined by a single specification. It is not just about how fast an aircraft can fly. It is not just about how far it can reach. It is not just about how small its radar signature is. What matters is how effectively the entire system can work together. That is the biggest lesson from the evolution of strategic bomber technology. From aircraft that relied heavily on physical capabilities, to aircraft that increasingly depend on information. From individual platforms, to networks, and from simply carrying a payload, to becoming part of a much larger system. The B-1B Lancer and B-21 Raider are ultimately more than two aircraft from two different generations. They represent two stages in the evolution of air power. One demonstrates what can be achieved when speed, range, and payload capacity are priorities. The other demonstrates how stealth, sensors, software, and connectivity are increasingly shaping the design of future aircraft. And perhaps that is where the future of air power truly lies. Not in a single aircraft operating on its own, but in the ability of different technologies to work together as one system. Because in the modern era, the most important aircraft may not necessarily be the fastest or the largest. It may be the aircraft capable of seeing more, understanding information faster, staying better connected, and remaining relevant as technology continues to evolve. If that is the case, then the B-21 is not simply the successor to a long-standing tradition. It is a glimpse into how an aircraft can become part of a much larger networked air power system. At the same time, the B-1B demonstrates that older technology does not necessarily lose its value overnight. In many cases, the future does not mean replacing everything. The future means combining legacy capabilities that remain useful with new technologies that offer different advantages. And that is why the combination of the B-1B Lancer and B-21 Raider is so interesting to study. Not because they need to be compared as winners and losers, but because together, they demonstrate how military aviation technology continues to evolve. From speed to stealth, from platforms to networks, and from individual capabilities to integrated power. That is the real new era. Lessons for the audience. From the relationship between the B-1B Lancer and the B-21 Raider, we learn that true superiority is no longer measured by which aircraft is the fastest or the stealthiest on its own. In the modern era, the greatest strength comes from collaboration, connectivity, and adaptability, where legacy and emerging technologies complement each other within a single, integrated ecosystem.